Hi everyone, and welcome to my channel. I'm starting this journey focused entirely on algorithms and data structures. But with a twist, this isn't just about solving problems, it's about truly understanding the approach behind each solution. I know there are already tons of DSA channels out there, but I wanted to create something different, a space where we learn together step by step without the pressure of being perfect from day one. So, whether you are just starting out with DSA or you have been struggling to find that moment, let's try to crack this code together. Are you ready? Let's dive in. Now, I want to be completely honest with you from the start. I'm not some coding genius or algorithm expert. I'm just someone who has been on this DSA journey, made plenty of mistakes, and figured out some techniques along the way. My goal here is simple: share what I have learned and hopefully help others who might be going through the same struggles I did. And here's the beautiful part: if you have a more optimized approach or a different way of thinking about a problem, please share it in the comments. Now, I do have one small request. Let's keep our discussion constructive. I'm all for learning from different perspectives and even corrections when I'm wrong. But let's remember, we are all here to learn and grow together. Sound good? Let's talk about something real for a moment. That sinking feeling you get when you're starting a problem for 30 minutes, then peek at the solution and suddenly feel like you are not cut out for this. That guilt, that voice in your head saying, maybe I'm just not good at coding. I have been there. We have all been there. You spend hours on a problem, finally check the answer, and think, of course, why didn't I think of that? But here's what I realized. Maybe we are approaching this all wrong. Maybe instead of jumping into the deep end and then feeling bad about needing a lifeline, we need to build our swimming skills first. What if there was a way to learn that actually builds your confidence instead of crushing it? Well, that's exactly what we are going to explore today. Think back to how you learned math in school. Did your teacher throw you a calculus problem on day one? Of course not. First, you would work through examples together. The teacher would solve similar problems step by step, explaining every move. Then, and only then, would you tackle the homework on your own. You built patterns, understood the why behind each step, and developed confidence gradually. So, why do we approach DSA differently? Why do we jump straight to random lead code, hard problems, and expect to magically understand complex algorithms? What if we applied the same proven learning method to DSA? What if we treated algorithm patterns like those textbook examples, mastering them first before attempting the homework problems? This is where my approach gets interesting. I have been using Neat Code as my textbook. It's beautifully organized by patterns with clear explanations and a logical progression from easier to harder concepts. Phase one is all about building that solid foundation. We will work through neat codes curated problems together, understanding not just how to solve them, but why we solve them that way. What pattern are we using? When do we apply it? What are the telltale signs? Then, in phase two, we take those patterns to lead code, our homework. Now, when we see a problem, instead of panicking, we can think, wait, this looks like a sliding window problem, or this feels like I need two pointers here. And here's my promise: I'll not only guide you through some lead code problems myself, but I will also give you the tools to recognize which problems to tackle first. No more random problem hunting. Let's talk about the elephant in the room: time and space complexity. I know. Big O notation can feel like learning a foreign language. But here's the thing. I spent a lot of time figuring out how to break down time complexity and space complexity in a way that actually makes sense to a normal human brain. No more memorizing formulas you don't understand. We will approach complexity analyzers the same way we approach everything else, step by step, with clear examples and always asking, but why does this work in this way? By the end of our journey together, you won't just be able to calculate time complexity, you will actually understand what it means and why it matters for your code. Here's how each video will be structured. And I'm sharing this because I believe in transparency. Some problem might take us 15 minutes to fully explore. Others might need 25 minutes, and that's okay. We will always start by really understanding what the problem is asking. No rushing here. If we don't understand the problem, we can't solve it effectively. Then we will brainstorm approaches together. I share my thought process, including the dead ends and wait that won't work moments, because that's real problem solving. The coding part will be live, no magic, no hiding mistakes. You will see me debug, refactor, and sometimes say, actually, let me try a different approach. And we will always end with understanding the complexity and discussing potential optimizations. Here's what makes this channel special. It's not just me teaching you, it's us learning together. When you solve a problem differently than I do, share it. When you find a bug in my code, call it out. When you have a question about why we choose one approach over another, ask away. But make sure it's polite. I genuinely believe that the best learning happens in community. Some of you might be just starting out, others might have years of experience but struggle with specific patterns. Everyone brings something valuable to the table. My role is to facilitate this learning, to provide structure and consistency, and to make sure everyone feels welcome to participate regardless of their current skill level. Thank you so much for taking the time to watch this introduction. I'm genuinely excited about this journey we are starting together. Our next video will dive into arrays and hashing. We'll start with classic two-sum problem and really break down the thought process behind finding an optimal solution. Remember, every expert was once a beginner. The difference is they didn't give up when things got tough. They found a way to learn that worked for them, and they stuck with it. I believe we can do the same. I believe we can turn DSA from this intimidating monster into a toolkit of patterns and techniques that actually make sense. See you in the next video, and let's start building those algorithm muscles together.